Alright, so today I'm talking about endothermic and exothermic reactions. We've talked about this before, but there's some stuff I want to add to it. And I'm covering it again in school, so I will cover it again here. So this is going to be kind of time or reaction process, so time. And this is going to be energy. Energy. So this is going to be my endothermic, which means to take heat in. And then this is going to be exothermic. We know based on our sign of delta H. So delta H here is positive, or is negative, and then delta H is positive because we put energy in, and we're going to see that show up on the graphs here. So here I start out with my, this is my products. I'm going to have a hump for my activation energy, and then we slide down the hill. So from where I started to where I ended, this is delta H. And so we can see that delta H went down. I went down from here to here, down the hill, so delta H is negative. So this is an exothermic reaction. This here, this distance, is an endo, or is the activation energy required. Activation energy. And another thing to note is we have a point up here called the transition state. This is when everything is broken apart, but when you're in the transition state, everything can still fall backwards in the reaction. So, transition state. The same thing happens with this endothermic. So I'm going to start at the same place. They're going to gain some, but I'm going to have a higher activation energy and they come down. But I want us to see here that still this distance between where I started and where I ended is still, this is a positive delta H because the value we went up. So delta H is positive, energy was added to the system. This big distance here is my activation energy. And then once again we have our transition state right on top. And so that's the difference between endothermic and exothermic reactions. Yeah.